Okay, we're going to go technical and fast. Now, okay, open your catalog. We're going to go from 7 to 9. Okay, we will start with page 8. Page 8 is a big deal. We talked about the knock already. We talked about the vein. Now we move all the way to the very front of the arrow. Okay? This is where Firenock got a ton of his patents. We got our AeroConcept. We got our arrow insert A. We got our arrow insert H. We got our AeroConcept 1. We got arrow, and also the moment we go back to the back, arrow bushing. So this alone, there's 7 separate US patents right here. And now I will show you how all this arrow works. Okay, as you know, there's so many arrows out there in the market. We already handled the knocks, we handled the veins. Now how do we possibly handle the insert side, where the business side is? As we all know, we need a broadhead or a field point, unless we shoot gluing points. Now, how do we handle that? As you can see on this page, go on to this. You see that on page 8. The top side, you see there's 8 of the all inserts. Those are called arrow insert A and arrow insert H. Let me define what arrow insert A and arrow insert H mean. Okay? Arrow insert A is a trade name we have. The word A means angled. That means at the back of an insert, that is a 45-degree angle in it. And I'm going to give you one of them so that you can see and how much it exaggerates. That's one of the most exaggerated arrow insert H. Okay, look at the back of that corner of the insert. You notice there's a 45-degree chamfer right here? Put your finger on it, you can feel it. Right here. It's not flat. At the back of this corner. That's my arrow insert A. You go into it, reversed. Why is this such a big deal and one of the most important part of the original arrow insert system? Because with this system, imagine this. I machined this insert so that you got a 45-degree reverse taper here, which is A. If you got an arrow like this, just like the page 8, you notice the drill with a chamfering tool right there? Imagine you put a 45-degree bevel on this shaft. The moment when this shaft mate with this insert, what does that mean?
It controls where it's going to be. It won't move back and forth this way. It's going to grab right into that 45.
To a certain, yes, that is true, but that was not the main reason.
Concentric. So.
Imagine if this insert, the ID is 297,000. Your shaft is 300. When you put the two together, you got 3,000 of plate. Am I right? But if the insert is like this and the arrow shaft is like this, the moment it come together, you are absolutely guaranteed the concentricity. That's the first step. The second step is that when the arrow shaft hit the target, everybody say the arrow behave like this, right? But the arrow also do radial oscillation. That's the reason when you start shooting super heavy arrow, ultra fast arrow into a target, what usually happens? You got mushrooming. If not, the insert will be shoved into the shaft. Why is it happened? Because imagine this, when you have such high pressure, the moment you hit it, okay, the tip of the arrow is pushing back. The arrow shaft itself is doing cylindrical oscillation. The moment we reach the maximum point, the entire thing got shoved in. Now, using an arrow insert A concept, the moment is like this, the shaft is like this. The shaft trying to do a cylindrical oscillation. Can it do it? Answer is no, it's encapsulated. The harder you push, the deeper it go into the insert. we technically eliminate the possibility of mushrooming altogether. That is the reason you look at every single arrow insert on everything we make now. We used to have arrow insert D. Arrow insert D only had 2 shoulders. Those are pretty much going to phase out. There will be no more arrow insert D, hopefully by next year. But arrow insert Ds will live on as arrow insert H. That means when you make A and D together, it becomes H. What is D? See this insert have 2 steps on it. See that? The first one and the second one. The word D stands for double. They handle 2 shafts or dual shoulder. What is that such a big deal? Well, if you build anything, if you know my stuff, the moment you say AeroConcept, that's what it is. That is one of the biggest deal that literally changed the archery world, is the double shoulder deal. If you talk to any of them, since you are coming in for certification, this is what you're learning. How that double shoulder insert with the reserve taper can change the behavior of arrow altogether to the point of ridiculous. If you understand what this will do, everything you know about archery really throw them out the window. It is that exciting. And this year, coming to this class, I'm going to talk about AeroConcept 2.0 after we finish this part. We show even more excitement. Now with the secondary shoulder, why is such a big deal? Why can't we just like put another tubing on the back? The answer is that if you just put a tubing on the back like typically some people do in the early 60s and 70s and 80s, they say, oh, let's put a tube in the shaft to make the arrow heavier. What does that really do? It do absolutely nothing. It just makes the arrow heavier, period. The arrow shoot like crap because they have no consistency, you have no consistency, you have no arrow to arrow to arrow matching. They all shoot differently. Now, with the secondary shoulder, we control the internal secondary shaft. I know you guys may not know what that is. That is what AeroConcept is about. The whole idea is that when you're able to control the front of the shaft, we know that the moment you use arrow insert A, which apply to every single arrow size I make, look at that. In 204, I have that for the first 3. See 204, 20A, 20S, and 20T. If you know the code names, I will try to give you an idea how this was named. The first character, A, means arrow insert. The second word, I. AI means arrow insert, and the third character, A, means that you only have a reverse taper on it. If you see the third character as H, that means that both have the reverse taper and also have the double shoulder. And this year we get some new stuff, but the next 2 characters, like the 20, means 0.20, and the last character is material. So when I say AIH20A, means that it's arrow insert with both specification in 200,000 size and is in aluminum. That's how you read that. But then you notice that on the next section, AIH20A, and then you go AIH2LA. Well, how come this word L? Because the 200 series is so good, we actually make another set, which is the lighter version of it. The word L means light in this case. Of course, 3 sizes. Then you go to the next one. You see that the AIA23S means arrow insert in arrow A's in the 2300 size, which is your H size. The word S means that's stainless. Anybody want to marvel or wild guess what that insert is for? Since I tell you for H size, name a few arrows that use that. Full metal jacket 6mm, your Michael Waddell, your Hacks, your Bloodline, they all use that, your Ion. Then you see the next one, you got 4 of them. The AI, you can see the AIA24A, means that arrow insert A in 24 size, which is your 240, 244, 246, 245. The word A means aluminium, the next one means stainless steel. That means this too is used for your simple 240, 246, 245 build. The moment you go lower, see the AIH24A and 24S, that means this is for your complex build with AeroConcept in it. because you can see the second shoulder coming in. Then the AIH 30A, 30S, those two are for your crossbows. That's where you build your arrow bow, your monster boat, your arrow. That means your Black Eagle Executioner, your Gold Tip, Quest, they are all of this size. That's your 300. Now, if the customer just don't want to pay for the AeroConcept, they want a simple, reliable insert, we still give them the good stuff. That's the AIA 30A. That means you have the same features of the above without the carbon tube. You can see that there's no second shoulder. But you also have the reverse taper. And that one is for the, same again, Black Eagle, your Gold Tip, your Victories. The next one, AIH 3GS, which is the one you're holding. This sucker is 100 grain. There's an arrow bow gyro system now. You notice how thin the wall is on this side? That's for ultra high speed, high FOC, ultra high rotation deal. This is the stuff you put an arrow, if you go ahead and put the arrow dagger on it, on a sculpted Oculus, at 100 yards, you'll go through a class 3 safety vest. Why a 44 man can't? Serious.
That's interesting.
Yeah, because somebody already did it, so we know it happened. So the next one you can see the AID 31A. See that? You still have the D. That means this is left over. You still have the double shoulder, but you do not have the A on it. That means if you shoot this into anything hard, the arrow got a mushroom because it doesn't have the arrow insert A on it. The next two, this two is exciting. This is what we bring out to the market this year. This brand new patent. It's called the Destroyer series. I'm going to let you each keep one of those. This is really a fun system that we made. This thing is definitely not cheap. You can see the machining is more involved than ever. You notice the insert front is actually tapered?
What is that angle?
30. How come all of a sudden you need a forward angle? Every single thing in the world need a backward angle, right? How come it's going forward again? If you look at it, this piece have our two pattern. You got an arrow insert A capability on the back of the shoulder. You got a double shoulder plank. What's going on with the front?
Well, you told me, but I still wonder, you told me it's legal, but I still find that something that probably would be, I could see it being protested or something, as far as knocking off your opponents for target shooting, as far as just hitting and cracking shafts.
Right, but actually because it been used, but was not executed as precise as what I did. What's my 8mm? I need an 8mm box.
Are these the ones with the 6mm points going to?
Yeah, 8mm points.
No, 6.
9. I don't want 8mm box. It is go on. If you look at the picture, it's on the page 9 on the very bottom. Those are called the destroyer points. Okay, that's a brand new design that we come up with. The field point itself is only 6mm, which makes it hunter class legal, because you can actually have a removable field point on an insert. Now, there's no rule against a smaller field point, because they already did it. They just didn't exaggerate it. Because if you shoot a Magnum class and you shoot an 8mm field point, you do have an insert that took smoke just like ours, except it doesn't have the features and characteristics like ours. Because if you shoot a Magnum, you put a normal 8mm point, it's going to look like this and then a point, which has already been used for the last 20, 30 years for anybody who would want to shoot a screw-in point using, say, a Fat Boy or a 6 or the line jammers, all those target shafts. But now I actually go one step further. I make the point as small as possible. I make the shoulder as wide as possible, still maintain a certain angle to it. So you become, imagine the point come down like this, now I give it this and then back. Now what does it do in a 3D environment? You allow your points to squeeze into anybody. If there's 3 arrows in it, they're hogging the ring, hogging the spots, right? When your arrow goes into it, first of all, you have absolutely no glance out because your point is only 6 millimeter. But when you touch the shaft, being a stainless steel or GR5 titanium, which is super hard, guess what happened to their shafts?
Goes bye-bye.
They all pretty much bye-bye. Because when you go in that moment, you go in the side of the shaft. Answer is that if they hog in the 11 ring, you use a normal 9 millimeter point going in. You're gonna glance out. You're not gonna touch the 11 ring anymore. But this one go in, you want that 11 ring, you push anybody and everybody aside.
That's why you call it destroyer, right?
Correct. That's the reason it's called a destroyer. But then on the range, you find out that anybody will shoot your arrow. Say you are now in the 11 ring. They come to you on the side. When your arrow crack, unless they Robin Hood you really don't care. You know why? You got a secondary tubing right here. You just protected your shaft because if they crack your first shaft, your arrow will still shoot the same. That's the beauty of the AeroConcept destroyer system. Now that pretty much concludes anything on page 8. Now I want to go to page 9. You notice that we have all these points look so weird, isn't it? You notice that we have all of them on one major features. And I want to show you the difference between the history of what we did. You look at a 250 grain. You notice the O-ring is just a little bit lower than that 175 grain. The 175 grain is based on arrow point effect technology 1.0. The 250 is based on the 2.0. The difference between 1.0 and 2.0 is that the 1.0 is right underneath the neck, which is a great concept, but it's not ideal if you hit that thing at 30 degree. Because if you hit that thing at 30 degree, the weakest link of that point is right underneath the neck. The O-ring is 1 millimeter. The shaft is 5.5. That means at that moment you only got 3.5 millimeter crack point. But since in the 2.0, you see I moved the O-ring 2 millimeter below the point. Now that neck is a full 5.5 plus a 45 degree chamfer like this, using the new AMO standard. So right now we just up the strength of that field point by 300%. Try break it. Now you notice that's the same thing we did in the destroyer points, but we go one step further. Behind the destroyer point, instead of a normal 45 degree reverse taper, it's actually a 30 degree. Why is it 30 degree? To mate with this. So that when these two mate together, you cannot possibly rock it because they literally sit. It's like an empty pyramid sitting on another pyramid at 30 degree. So when you rock it, you have to rock the entire shaft. You cannot possibly do this, which means that it's not crackable. So if any of the customer buy this series, they can break their shaft all day long. This whole thing will be 100% recoverable. Oh, I forgot to mention, go back to page 8. See the last two pieces right there? That's our attempt to go into the latest shaft, like the Gold Tip 9.3 and the Eastern Super Drive. They are the 320,000 series. So we are moving slowly into that. And by next year, hopefully I will cover all the way up to 360 size, which is the 2764, 26564, 2664, and the 2564. And even cover some of the 2464. So you can see our offering is going to be significantly bigger. Yes, there's that many sizes out there. Most people just never believe it. Now, why do we make all those different sizes viewpoint? You look at the 9 millimeter. The 9 millimeter is our biggest deal for all the target guys. The 250 is for indoor 3D, when you want to shoot Lancaster or shoot Vegas. The 175 is to match our broadheads and all the rest. You see, we go all the way to 45 grain. But then you notice there's another 45 grain. You see the shape of that so differently? Why do we make a 45 grain with that specific shape? Didn't we already offer a 45 millimeter in stainless? This is where I learned the problem, and this is why I'm trying to solve it with a destroyer. When you make a 45 grain in stainless, see the angle of the tip is actually less than 45 degrees. But because we only have 45 grain of material to work with. So what can you possibly do to make it happen? In the case of the Hunter class, or even Pro class, you can actually use a different material, like titanium. Titanium is 45% lighter than stainless steel.
That shaft is just, that second section is just so thin.
I know that, but you still find titanium, it doesn't matter. It's 250% strength of stainless. So, and on top of that, all the force is on the top, not on the middle section. You're just holding it together, so it doesn't matter.
That's amazing, it's that thin.
Yes, it is. Most people never believe it until they put one in their hand. And believe me, that thing is not cheap. When I first come up with it, that piece, we are running that piece at the titanium section portion. That, I'll give you guys one just to get a feel. This thing is, when I first come up with it, is $90 a dozen.
And how much stronger did you say this is?
250% strength of stainless. A stainless is about 430 MPa, this is 850. But 330 MPa, this is 840 to 850 MPa. Can you imagine? Now, it looked just like a 100 grain fill point, but you can see that. The weight is unbelievable, isn't it? That thing is only 45 grain. Now, if you're interested, I'll get you another one so you can get a feel of it. This is what a 45 grain stainless. Yes. See the difference on shape? That's the beauty of working with material. The moment you have the material now, this is possible. Imagine a glance out. Yes, sir?
Do you have these for only 315 diameter, or they come for 300 for the 22 series target shafts?
The beauty of it, 9mm is just between 200 and 315. So you work all the way to 360, 240, 340 size. That means you can shoot the same identical one, even using an Eastern Superdrive 26. It still works.
These are the inserts.
Yes. The inserts only 32. You can go up to Eastern Superdrive 22. The Eastern Superdrive 23 or go to 93. Those are 320,000, which I call it the 2465. Anything beyond that, we need to rethink that whole process.
You're going to have these for 22 series? You're going to have these for the 22s?
This will fit the 22.
22 series shafts?
They will fit the 22 series, yes. The 9mm will fit the 22 and also the 23.
But you have the destroyer inserts for 22s?
No, the destroyer insert only happens for the 23. Yeah. Because if the 22 will not work with the destroyer. The ratio is too close. I will have, later I may have the destroyer for the 26, but not the 27. The weight will be too heavy on the 27 because it's still a diameter. You may have to go a different route on it. Any question on the field point so far? Now you notice that I have every single size from 45 all with the way to 175. Which means that if you're a target guy, just like you see a very top picture, you see that? The insert, the point, and the tube on the very, very top of page 9. If you want to maintain your grain weight, you have the tube, you have the insert. What can you do to maintain the total weight and still get the speed? Because original, no matter what you do, when you want to shoot a 325 grain arrow on a 63-pound bow, you don't have a choice. That's your best speed. So if you put a tube and you put an insert, the weight had to come out somewhere. Now you know why we make 45 and up to match it. So what I'm doing is that I'm pulling the FOC for the front of the arrow into the midsection of the arrow, which is where the carbon tube and the insert is. So in other words, I'm pulling the entire weight of the arrow away from the front to the midsection. Now what does that do? Now, in the old days, if you put this with a blazer, you're gonna regret it. The arrow gonna fly sideways all over the place. But see, remember, when you shoot arrow wing, there's no drag. So no matter how small the difference is enough. That's what the big deal is. Any questions so far?
This isn't a stupid question. As far as most of these going in there, most of them use that extra carbon tube or something. That generally goes in first on pretty much all of your design.
Yes, actually, when we go one step further, when you go next page, I'll show you version 2.0 about that. Technically, this is how it goes. Arrow insert A is for a simple build, no carbon tube involved. Arrow insert H is with your carbon tube in it. Because A have no carbon tube behind, it cannot support the secondary carbon tube. Now people say, okay, my arrow shoot the best if I put 49 grains points. How do you find a 49 grain point or a 52 grain point? You can't. So that's the reason in 2018, we go one step further, and on page 9 you see there's 2 spacer system right there. We actually now let you crush on the copper side. We let you add 4, 5, 6, and 8 grains in the front. So all of a sudden, you can now compound them and change the weight of your point by adding that. That works exceptionally well with AeroConcept, the AeroPoint 2.0 design. Now then, why do you have this titanium spacer? Now I will going to revisit this when we go to broadheads. Okay? Now let's go back to page 7. You notice everything we talk about it is a 202 and larger. What happens when you deal with a 166, 165? There's a few different approach. Some people put what you call it 100% half outs. Some of them use reverse half out. And some company go all the way to use much smaller thing, like what you call the deep 6. Okay? When you go that route, you're no longer using ATA standard, which is your 832 threads. And I can draw this out and show you the major difference. And I go back to what had worked. This design is not mine. This design was actually come out in the days of the Beeman. When Beeman was making the carbon hunters, 60, 70, 65, 80, that kind of deal. Imagine this is your carbon shaft. This is what everybody is doing. They will have an insert that goes like this, comes up all the way, and your fuel point will actually, or your broadhead, will actually come in like this. And then of course the fuel points on this side. What does this design, what's the biggest flaw of this design?
Weak point where those two.
Exactly, the weak point is right here. Because all of a sudden, this entire front insert, plus your fuel point, your falcon point is here. That means you now have this much thing to bend on this tiny bit, which is your 166 ID. That means all your Black Eagle X impact, your Eastern injection, and so on, they all bend right here. Because it's supporting the entire insert that holds the entire fuel point. How perfect can you glue this? Now there's another problem. You are dealing with a 166 class shaft. How is that shaft being built? It's built with a centerless grind, which means the thickness of the shaft is never perfect. Well, if the thickness of the shaft is not perfect, you put something inside the center of that shaft. What are you doing? You're banking on the imperfect thickness of the shaft. How true will this thing spin? It won't. If it spin right, just means that you have to off-center this piece to compensate for the thickness difference to start with. So how do you overcome this? You overcome this by using the outside approach. Same shaft, with the outside going out, and then with the fuel point coming in like this, with the thread actually semi-go into the shaft. What's the falcon point? Here! Wait a minute. Isn't this point have the outsert, the field point thread, and the shaft, all three? So all of a sudden, the weakest point become the strongest point. How can you bend? You couldn't. That's the reason for the last 7 years of selling outserts, I do not have one bend. No, not even one. And if you look at the archery as a world, every single Australian, German, US, anybody who get those cheap 166 shaft from China, they all call me for their outsert. High velocity from Australia, so-called from Australia, they all use this outsert systems. Because it worked. It's as simple as that. So why did some people why not everybody make outserts if this is really that good? The problem of making outserts, first of all, expensive. Second, I own the patent to circumvent this problem. See, if you make an ordinary outsert like this, say out of a screw machine, and you put it on top of the arrow, when you shoot into a back target, guess what you need to do? It got a wedge effect. That means the moment when the shaft goes into the target on the meat, the moment you pull back, it tightens. See, it can't come out. It can't come out because this is wedge. The pressure is building. The more you pull it, the pressure builds. So how do you circumvent this problem? If you look at my page, which is on page 7.
You put a bevel there?
Better than that. The bevel is a good point, but if the bevel builds, what you do is see those channels right there? See, every one of them have lines on it. You look at it. If you've got a chance to take a close look at the Firenock outserts, which I do not have any with me, every one of the line are different width and different depth. What it does is that it behaves just like a potato knife. Have you ever seen a potato knife before? A knife, you got a few channel on this side. The more you cut it, the air goes right in, it falls off. Or what you call a fresh bread knife. You know this knife is not straight edge. You got a few bevel in it. Now by doing so, the moment when the arrow was when you pull the arrow back, when the outsert was hitting on the very edge of it, what it does is that the very edge of that bevel behaves like a knife edge. And the moment you go there, it actually cuts internally onto the target. Well, when you got a knife edge and you put pressure, guess what? If it cuts, it comes right off. Which also explains why an outsert of Firenock shoot into an animal. You don't have to like the traditional beam and take a knife out, follow the arrow, cut the meat first before you take the arrow out. Because the moment you do this, the very edge, which we call the blood channel, is actually cutting the meat. Which make ours able to work on back targets. You act on foam targets, you work on meat. That actually is patent. And the patent number is right there, the 8668605. We actually trademark it, blood channels. Which also gives you one very interesting thing. We find out that when you shoot this thing into animals, the fact is that when the animal, the more you shoot it, the blood comes out. The blood goes into the channel and actually lubricate as the flow goes. So the blood channel is actually quite a correct name for that exact. And that is what we handle all the 166 G-Knock size arrow. And yes, there will be no AeroConcept with the G-size arrow. Since we're on this page, we'll go and talk about the 6. The page number 6 is where we have to call a square peg in the round hole. Since we're talking, we want to finish every components before we move into the next round, AeroConcepts. This is a piece that, remember I told you all the Firenock, the biggest knot we will make is the 300. So how are you going to deal with the 2764, like your Magnum, your full bore, your Super Dry 26, your Black Eagle PS 26, 25, 27, or the big shafts? The moment you put an insert and a knock, you are pushing close to 30 grains on the back. Now how can we lower it to the point that it will work? Why can't we just mow a big knot like a 26 or 2764 size? The answer to that is that that knot will be ridiculously heavy and it will not hold right. Because when you go to shaft of that size, the external wall is so thin, it flex so much. You put a nut in it, it's not going to work. So what we do is that we do the whole thing in reverse. And we approach it from a different way. Right here. I give you guys some samples, so at least you got a feel of it. Take a look at it. I'll give you some numbers, so at least you have some idea what it means. On a 2764, if you put a shrill bushing with a G-knock, you're pushing 38 grain. We designed ours to fit an A-knock, which the knock itself is 5 grain. On a 2764, our weight is 17. So we are not talking about a third lighter. We're talking better than half and beyond. And in the case of 2364, our pushing plus our knock is 12 grains, which is lighter than a standard S knock. Now we're pushing the whole envelope the other side. Because when you're in target size, target shaft, imagine one day you go out there with AeroVing 3, you've got a 6% FOC, and now the wind is blowing 15 miles per hour. How are you going to make it right? Very simple. Since you're light on the backside, you can move from a 45 grain point to a 55 grain point. Since you're able to remove it just like that. Do a little bit dialing, you're back in. The fact is that you can change your point weight, you can change your knock at will. That's a big deal. Because you're not limited what you have in your quiver. Our entire toolkit can help you customize what you need that day. I mean, like we all like to shoot super low FOC, but that day when the 35 miles per hour is blowing, you're going to need that FOC a little bit. Yes, the AeroVing is going to help you, or you can help you, but you still need the point to where you want to aim. There's no way around it. You need the control. Yes, if you do indoor 3D, you don't have to worry about that. But there's not too many indoor 3D tournaments besides Buckmaster. All right, that pretty much covers everything before we go into AeroConcept. The AeroConcept is going to be very involved, and I want to spend more time with it. Any question up to this point? Think through it. I'll give you a few seconds to think through it.
You have these now for 26 and 27 series?
Which one?
You have these for the fat shafts?
Yes, I have all of them. You can see that the chart is up here.
But I mean like out right now? Like.
I believe so.
Where's the nearest restroom?
Right there. You can shut that off if you don't mind.